Hey, it's Mr. Leatherwood.
And Mrs. Hannah.
And
Mrs. McGowan.
she's
Woo!
hanging out with us today.
Surprise guest.
And look, we're playing with blocks.
Oh, I love to play with blocks.
Yeah, they're pretty.
They are. Lots
Right.
of different colors.
All right, we're going to talk about prime and composite numbers today.
Yay, finally.
Yeah, finally.
Gosh, this is one of my favorite things.
Is it?
It is.
Well,
I
that's
love
good. And we're going to use arrays.
Cool.
Arrays. Do you know what's an array?
An array is when you make equal groups formed in lines. A lot of times I've seen them in dots, in squares, even a row of hearts, but they're equal rows.
Okay. And so we're going to figure out prime and composite using those?
Yeah, I bet we could.
Okay. Well, I got blocks. There's
Cool.
my hand. I'm
Okay.
actually here today.
Yay. Hello,
It's not
Mr.
whiteboard. You can actually see my hand. Isn't that cool?
Live action.
Yeah. Okay. So let's talk about making an array. Let's use the blue ones
All right.
because I've
I know my colors. I can find the blue.
preemptively counted them.
Mm-hmm.
Is that a word, Miss McGowan? Is that a word?
I think so.
Preemptively. Okay.
I think you're making this more challenging for me.
I am. You like how I mixed them all up again?
Yes, yes. Could have kept them together, but no, that would not be as fun.
Okay. Well, I will give you a hint. The blue ones, we're going to do arrays for the number 7.
All right, for
So-
7.
So 7.
There's 6. I
So
got
2
my
times?
equal groups,
Yeah.
and that's 7, but that doesn't work. What about
And that's the thing about arrays. It always needs to make either a rectangle or a square, right?
yeah, that wouldn't be a rectangle,
Okay.
but that would,
That
and that
would.
would be a straight line. Is that an array, even though it's just one?
Yeah, we could do.
Okay.
You could say it's 7 times 1. So
oh yeah.
kind of when we were doing multiplication, we did 7 times 1, and that gives us 7 units.
Just like area.
Yeah.
Okay, length times width, 7 times 1. Well, then I know if I could have one row of 7, could I have 7 rows of 1?
Yeah.
Okay.
So there's 2 arrays to represent 7.
And it counts as 2 arrays, even though they really kind of look the same, but it shows that you can flip it, because in multiplication the order doesn't matter.
So it's like 1 times 7 and 7 times 1.
Okay, I get it.
So how many factors then does 7 have?
Well, I have 2 arrays, and 7 times 1. It wouldn't be 4, because this is 7 and 1, and this is 7 and 1.
So it only has 2
It only has
factors.
2. Okay.
1 and itself.
Okay, yeah.
So should we go ahead and give the definition or come back to
Yeah,
it? Go ahead and give it?
let's do it.
All right.
Okay.
So since 7 only has 2 factors, has 1 in itself, it's going to be a prime number.
So it's 1 and 7. Those are the only factors. Because no other way I can do this. And I know I can't say that's 2 times 4. That would be 8. But I only have 7. So that doesn't work. I can try that. I can try that. There's no other way I can make a rectangle except for a straight line. That's it.
So 7 would be considered a prime number.
Okay, so that means it's prime.
Only 2 factors is the definition I always give.
Yep,
1 in itself.
1 in itself. And it has to have exactly 2 factors.
There you go.
Okay.
Let's try another one.
All right.
So we're done with 7.
Bye, 7.
Get rid of 7. Let's
right.
go to purple.
Purple.
Purple's pretty.
Pretty purple.
Or fuchsia. Magenta, maybe?
Magenta.
Magenta.
My kids used to watch that show with the dog on it, and there was the blue.
Blue's Clues.
And they had the magenta.
Yeah.
That was a long time ago.
I used to work at a print shop, so magenta is one of the 4 colors you use to print with.
Hey, see, look how knowledgeable we are.
Yeah. All right, so if I remember, I think the magentas were 10. So let's do
right.
factors of 10.
Well, I know I'm going to just go ahead and start with my 1 and 10, because I know 1 times a number can make anything, so I can make a straight line. But I better count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not going to work. But there's 10, and this would be 1 times 10, right? Okay.
And we could also do up and down. We could do 10 times 1.
That's right, 10 groups of 1, 10 times 1, 4, 5, 6, 7, 8, 9, and 10. I know my arrays have to be straight. Okay.
Could I write it to show it?
Yeah.
Sure.
Thank you, Miss McGowan.
So then I would do 10 times 1 equals 10.
Yep.
And then 1 times 10 equals 10.
Yep. Yep. And remember, we talked about this symbol means groups of, so it's the same thing if we were going to say it. That's 1 group of 10 and 10 groups of 1. Cool. Okay. Well, let's see if we can make another one.
Okay.
All right. I know 10's an even number, so I'm thinking I might be able to make groups of 2. 2, 4, 6, 8. That doesn't work. 10. All right. Well, that does make a rectangle. And it doesn't have anything left out. And it is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've got 2 on this side times 5. So those would be my factors. I have 2 groups of 5, and that makes 10.
Good. And then go
This
ahead.
has more arrays than 7 did.
And we could do one last one, right?
Oh, I could.
Oh, maybe not.
But if I had more cubes,
Yeah. Oh,
I bet I could make 5 groups of
5
2.
groups of 2.
2, 4, 6, 8, 10. So just in your mind, picture that.
All right. We messed up, huh?
You
Forgot to
could
count.
switch it sideways.
Oh,
Oh, yeah.
Here we go.
There you go.
And then
That
put
would be
it,
another one. Yep.
So they have more than 2 factors.
Yes.
Because it has 10, it has 1, has 2, and it has 5. So it had 4 total factors. So if a number has more than 2 factors, it's going to be considered a composite number,
Oh, it's not prime.
not prime. Prime only
Okay.
has 2 factors.
Even though it has 1, it doesn't matter. It has 1, 2, 3, 4 factors. It has more than 2.
Exactly.
Okay.
Want to try one more to show them different arrays?
Yes.
So we've done 7, we've done 10. Let's go to the green ones, and we'll
Okay.
do, I think we did 12.
Let's see. All right.
Do you want to get rid of the 10 ones and
All right,
to make
we'll
some
keep-
official?
Oh,
look at
Mrs.
there.
Mrs. McGowan is,
There's-
wow.
That's technical
That is
right there.
helpful. Awesome. Okay. Wow, there's a lot here. I'm just going to go ahead and take a guess that this is going to be a bigger number.
Probably so.
Okay.
I think it's 12,
All right.
and I bet you could guess if it's going to be prime or composite, but we'll show them using arrays.
12. Well, I'm gonna guess that it has more than 2 factors. So just by that, I'm gonna say it's not prime.
Okay.
Is that true?
That should be
Okay,
true.
That should. Let's see if I'm right. I've been teaching this for a while. I hope I'm right.
So if it was prime, it would just be 1 and 12, 1 times 12, and 12 times 1, because that would be only 2 factors.
8, 9, 10, 11, and 12. So there's my long one.
Okay.
All right. So that is 12 groups of 1, or 12 times 1. But if it's prime, that means, not prime, if it's composite, that means I should be able to make another rectangle that's not just a straight line. Because it has more factors. So let's just try this here. Let's see. That's 3 times 3. That's 9, 10, 11. Oh,
There
look,
you
Mr. Leatherwood and Mrs. McGowan, look what I did.
3 times 4 equals 12.
And how do we know it's 3 times 4? 3 down, 4 across, just like an area.
Yeah, which we did this week.
Yes. Wow, area and multiplication really do go together.
Is there any others? So we have 1 and 12 would be a factor. 3 and 4 would be a factor. Can you think of any others we could do?
Oh, wait, it's an even number. I know 2 makes all even numbers. So let's see if I can make groups of 2. 2, 4, 6, 8, 10. Woo, looky there, looky there.
Go.
Oh, this is a longer rectangle, but it's 12. There's nothing hanging out the sides. Those are arrays. Equal groups, lines. Let's see, 2 times 6. I have 2 groups of 6, and it still makes 12.
Very good.
So what are the factors of 12?
Want to write it in a little T-chart maybe?
Yeah, let's do that.
in a T-chart.
Yeah. Let me show you.
Yes.
Okay.
Can you show me that?
Yeah, so this is how I do it. Okay, cameraman and
Yeah.
artist.
You want me to take
artist
over
here.
shooting?
You can, yeah.
Okay. Oh,
Oh, it may get wobbly.
Hey, watch
All right,
out now.
so we're doing 12. So I do 1 times 12, 2 times 6, and 3 times 4. And I know once we get down here and they're real close together or maybe right next to each other, then I'm done. I like doing it this way because it also puts them in least to greatest if you go around like a
Yes.
U. And then when you're talking about common factors, let's see, we did 10 earlier. We did 1 times 10 and 2 times 5. Then if we wanted factors that were common, we could go back and circle things that were in common between the two.
The same.
Yeah.
Okay.
So we know that common factors between 10 and 12 would be 1 and 2. And we learned that last week.
I love looking at the T-chart. That makes more sense to me.
Yeah, it organizes it
It
pretty good.
is.
So now we know that these are the factors of 12, and that it's definitely not prime because both 10 and 12 both have greater than 2 factors. Where 7, when we did 7, sorry, I'm jumping all over the
Oh,
place.
no,
you got
that's
me.
fine. I got it.
1 times 7, they only have 2 factors, so we know that 7 is going to be a prime number.
It only has 2 factors, no more on the chart.
And then these 2 would be composite numbers.
And that just means it has more than 2. Is that right, Mr. Leatherwood?
That is right.
Awesome.
I think I get it now.
Yay!
Good job, Miss McGowan.
And that's it. That's prime and composite for you.
All right, guys, I tell you what, why don't you see if you can find 5 prime numbers and 2 composite numbers for us. Just list them on your paper.
Oh, that's good.
Yeah.
All right. We'll
All
see you
right.
tomorrow.
Bye, guys.